Welcome back, pre-algebra students. We're in lesson 15 and we're going to talk about the relationship between fractions and decimals today. As you can see here, I have a circle that has been divided into 5 equal parts, and 4 of those parts are shaded. 1, 2, 3, 4. So 4 out of 5 parts are shaded, so 4/5 of the circle. Now I can turn this fraction into a decimal simply by completing the division problem that is illustrated. 4 out of 5 is in a fraction the same thing as saying 4 divided by 5. That's really what a fraction is. It's a division problem waiting to happen. But a lot of times a fraction is just easier to think about and do mental math with than a decimal. It just depends on the situation. So in order to get to a decimal, all I have to do is complete the division. So 4 divided by 5 would look like this. 5 as my divisor and 4 as my dividend. Now I know that there is a decimal behind the 4, so I'm going to go ahead and put that in place. And since 5 is a whole number, I don't need to move the decimal place at all. I don't need to move this point around, but I am going to go ahead and put a 0 in just in case. So 5 goes into 4 0 times, right? Because 0 times 5 is 0. We can skip this whole step if we want to, but sometimes it's handy to go ahead and go through it just to put our 0 in the right spot, or to put our 0 in the decimal. So now I bring down my 0 here, and I say 5 into 40. Well, I know that's 8. 8 times 5 is 40. When I subtract, I get 0 remainder. So a fraction, 4 over 5, is equal to the decimal 0.8. Isn't that neat? By dividing our fraction, by completing the division that started by writing a fraction, we can turn a fraction into a base 10 number. The base 10 number, that just means that everything is counted in sets of 10. Whereas this circle was counted in sets of 5, we were able to turn it into something counted in sets of 10 and use it on a number line or in our number system. Let's see if we can do that for some other quantity. Let's try 3/8. Now we know that 5 is a factor of 10 and that we could have just doubled this and said 8 out of 10. But what about 3/8? 3/8, we can't double 8 or multiply it by anything in order to get to 10. So what we're going to do is simply do the division. So I am going to say 3 divided by 8. I'm going to put my decimal in the right spot, and I'm going to give it another 0. Let's give it a couple of zeros just in case. 8 goes into 3 0 times. That's going to be 3. I'm going to bring down a 0. 8 goes into 30 3 times. 3 times 8 is 24. When I subtract, I get 6. Bring down that other 0. 8 goes into 60 7 times. Remember, you can always keep adding zeros if you need to. 7 times 8 is 56. So we subtract, and I get 4. I bring down that other 0. 8 goes into 40 5 times. 5 times 8 is 40. And now I have no remainder. So 3/8 is the same as the decimal 375 thousandths. Isn't that neat? So you can easily turn a fraction into a decimal if you need to by dividing the numerator by the denominator. So let's look at another practice problem. I'm going to clear the page. And 3 divided by 8 was actually A from 15.1, so we're going to do B from 15.1 and turn 1 over 30 into a decimal. So let's see what that equals. Let's divide 1 by 30. And I have a feeling we might need a bunch of decimal places behind, or a bunch of zeros behind the decimal. So let's put some in. Let's put 4, just to see if we need them. If we don't need them, then we won't use them. So 30 goes into 1 0 times. Let's bring down the 10. 30 goes into 10 0 times. We bring down another 0, but 30 can go into 100 3 times. 3 times 30 is 90. When I subtract, I get 10. So I can put another 0 on here and get the same number. 3 times 30 is 90. And it looks like, bring down another 0, I'm going to keep getting the same number over and over. So whenever we keep getting the same number over and over, and we know when we have a repetition here where we keep getting a remainder of 10 and we add a 0, remainder of 10, add a 0, remainder of 10, and add a 0. If you keep getting this number, the same number over and over again, that means that this decimal is going to repeat constantly. We call this a non-terminating decimal. But this non-terminating decimal repeats itself, so it is a repeating decimal. And the way we show a repeating decimal is to put a line over the top of the digit that repeats. So in this case, we would write this as 0.03 with a line over the 3 to show that the 3 is what is going to continually repeat into eternity. So that would be our answer, 0.03. Now in the system, in the Jupyter system, there isn't a way to put that line over the top unless I change the character profile. And I'm not sure if I'm able to do that, but I can check into it. So if you are unable, if you don't have the symbol that allows you to put the line over the top of the number, the alternate option that you have for getting the answer correct is to write it like this, 0.033. If you double the numbers or the digits that repeat, just write them twice, then that's an acceptable solution for not being able to put the bar over the top. But the correct way in mathematics is to put the bar over the top. And I'm going to try to adjust our character symbol allowance to add this bar over the top so that you can write that 3 correctly. But if you just double it, if you don't see that symbol, then the system should mark it correct for you. And if not, I will. So now we know how to write what is called the repetend. It's a repeating decimal, but we call it a repetend. That is the actual number that repeats. Make sure I spelled that correctly. Yes. The repetend in this case is 3. And the bar that we use over the top of this, that bar is called the vinculum. I don't know why. It just is. Or I'm sorry, not vinculum, vinculum. So vinculum. I always pronounce it wrong. So the vinculum is the bar, and the repetend is the number that actually repeats. So those are two definitions that you want to write down. Okay, put all of that in your notes. All right, so let's move on. And let's do example 15.2. We have 3 fractions there to do. So we're going to write each fraction as a decimal number, and here are our fractions. We have A, which is 3 over 10. We have B, which is 2 over 5. And we have C, which is 3 over 20. So all we're going to do is a division problem for each one of these that turns them into a decimal. So we're going to take the numerator 3 and divide it by 10. Go ahead and set up our decimal and put in some zeros. Just go ahead and put in 3 just to see if we need that many. So I am going to divide here. 10 goes into 3 0 times, so 0 goes in first. Bring down my 3, bring down my 0. 10 goes into 30 3 times. 3 times 10 is 30, and I have a 0 remainder. So the answer here is 0.3. So 3/10 can be written 3 over 10, or 3/10 as a decimal. Stands to reason, right? Right, what about B? B is, we do 5, actually, sorry, backwards. We put the numerator in the divisor. I'm going to put 3 zeros here just in case we need them. I'll put my decimal up here, and I'm going to put 5 here. 5 into 2, 0 times. Bring down my 0. 5 goes into 20. We know 5 times 4 is 20, so 4 times 5, 20. No remainder. So the answer here is 0.4. 4/10. 2/5 is the same as 4/10. So let's try C. We're going to divide 3 by 20. I'm going to put in some zeros, put my decimal in the right place. 20 goes into 3 0 times. So now I bring down my first 0. 20 goes into 30 one time. 1 times 20 is 20. I bring down my other 0. 20 goes into 100 5 times. 5 times 20 is 100. Now I have a 0 remainder. So 3/20 is the same as 15/100. And that is how you would turn a fraction into a decimal. So now let's look at rounding repeating decimals and how we can write them succinctly and get rid of those roundings. So let's just jump into 15.3, and we're going to round 42 at 0.617 repeating or repetend to the nearest millionth, to the nearest millionth. All right, so first what we need to do is write this repeating, or write it repeating until you know it's past the millionth place. So I'm just going to write it 3 times just to make sure that I know it is past the millionth place in the decimal system. So I've just repeated 617, 617, 617 for a while. Now I'm going to figure out where my millionth place is. So 10th, 100th, 1000th, here's the millionth right here. So what I'm going to do is I'm going to look at, let's see, is that right? No, that's not right. That's not millionths, Tracy. Silly teacher. 10th, 100th, 1000th, 10,000th, 100,000th, millionth. That's the number I'm looking at right there. That is the place that I need to round it to. So I'm going to look directly to the right. That's the number I need to check. Is it 5 or more? Why did I write plus 3? 5 or more. Yes. So I can take all of this and make it a +1 for here. So 42.1 0.617618 is going to be this repeating decimal number to the nearest millionth place. That would be your answer. All right, so what I did was I just repeated the repeating decimal number, or the repetend. I repeated the repetend until I was well past the millionth position. Then I found it, I identified the place I needed to round, and I looked to the right and said, is that 5 or more? The answer was yes. So I was able to take all of this and round it up to 1 and add it to the place value that I needed to round to. So that is how you would do any type of rounding a repeating decimal. Let's look at the next part here. We know we could turn fractions into decimals, but we can actually take a decimal and turn it back into a fraction. So let's see the process for doing that. That's 15.4. So we have the decimal 0.041, and we want to turn that back into a fraction. So we know that this is the tenths place, this is the hundredths place, and this is the thousandths place, right? Well, if this is the thousandths place, then that means that this number is divided by 1,000. So all we have to do is say that in numbers. This number divided by 1,000, because it's in the thousandths place. Easy peasy. That is all we have to do in order to turn this back into a fraction. Now, once we do that, we can look at that number and see if we can reduce it. And if we can reduce that number, then we can get it into its smallest form. 41 is a prime number, so we cannot reduce this fraction, so it stays in this format. Let's try one more. Let's do 15.5. 15.5 wants us to turn 0.35, that's 35 hundredths, into a fraction. So 35 hundredths means 35 hundredths. Now we know that if something is a multiple of 5, or it can be divisible by 5 if it ends in 5 or 0. So that means that I can reduce the fraction by 5. So I'm going to divide by 5 over 5 to reduce it. And we know that when we reduce by basically the number 1, the value stays the same. 35 divided by 5 is 7. 100 divided by 5 is 20. When we do these decimals into fractions, we need to reduce whenever possible, and the answer that is going to be required in the Jupyter system is going to be the reduced version of the fraction. So if you leave it like this, the system is going to mark it wrong. So you need to go ahead and put it into its reduced form. That is one of the rules of algebra. I'm going to write this up here, and I want you to put this in your notebook. This is a major rule of algebra. Reduce fractions, that doesn't look like an R, does it? Reduce fractions always. If you have the opportunity to reduce a fraction, you reduce a fraction. We never leave a fraction unreduced. So, RFA, reduce fractions always. Major rule of algebra. We do not leave it in its original form. All right, that is all we have for lesson 15. Please put this in your notebook because it is mandatory. If your fractions are not reduced, and they can be, then points will be lost. and I do not want you to lose any points. So always reduce your fractions, and I will see you in lesson 16.